Alright, so we're working on derivatives today, and what I kind of want to go over with you is there are 4 or 5 basic rules of finding derivatives of differentiation, and one of them is the product rule, and it says this. It says that, right, we already talked about the power rule, and we've talked about sum and difference rule, and we have talked about the constant rule. So hopefully you already have those rules, and add to those rules this one. And it says that the derivative of f of x of a function times another function is equal to the first derivative of the first function times the second function plus the first derivative of the second function, here I got it color coded, times the first function, which kind of sounds like crap, but it's not bad at all. The first thing let's start with an example here. Let's take this. Let's say that our function here, h of x, and we're going to find the first derivative. So find the derivative of h of x. Let's say h of x is equal to 2x squared minus 3 times 5x plus 2. So this is, I guess, my challenge to you, and we're going to do it both ways. What you might want to do is, if it was something this straightforward, you might just FOIL this. And let's do that really quickly. So let's FOIL this, and we'll get 10x cubed, right? And then we'll get plus 4x squared, right? I'm just doing FOIL here. Minus 15x, right? Minus 6. And negative 3, this is negative 15. Oh, this should have been 4x squared, shouldn't it? Okay, that's what I was looking for here. So then if we take this, now this is h of x, isn't it? We expanded it. When we take the derivative, it should be 30x squared plus 8x, right? Minus 15 should be our derivative h prime at x, right? And all I'm suggesting to you is that we could do it another way, and we'll talk in a minute about why you would use this product rule instead of just expanding it, but I think the answer will be easy as you see other videos. Alright, so this is what I'm going to do here. I'm going to just use this rule right here. So this is what we're going to just use this rule right here. See if this doesn't work. So we need to get some pieces here. Right, we need f prime at x. So let's make a list. F prime at x is equal to what? Well, remember, f of x is this first one right here, so its derivative is just 4x, isn't it? It equals 4x, right? And f of x is already defined for us as 2x squared minus 3, so equals 2x squared minus 3, right? And then it says here that we need a g of x and g prime at x, so let's start with g prime at x. G prime at x and g prime at x, and g prime at x is, well, what's the first derivative of 5x plus 2? What's the slope of 5x plus 2? It's just 5, isn't it? And then g of x is equal to 5x plus 2. Now we're going to use this list that we made here, and we're just going to fill in the blanks. Fill in what blanks? Use this information to fill in these blanks up here, right? So we're going to fill in these blanks up here, right? So it says that we need f prime at x. It says here, so we'll discover our f prime at x is 4x. And it says we're going to multiply that times g of x, and we know that g of x is 5x plus 2. So it's 5x plus 2, isn't it? It says that we're going to add, so there's that plus sign. G prime at x. G prime at x is 5. It says g prime of x times f of x, and we know that f of x is 2x squared minus 3. So here's our 2x squared minus 3, isn't it? And let's see if we get this same piece here. Play like hell that we do, right? So all I'm going to do is the algebra here. I'm just going to distribute this into here, this into here, this into here, and here. And that comes back looking like this, doesn't it? Gives us 20x squared, right? Plus 8x, doesn't it? Now I'm going to distribute this positive 5, so plus 10x squared. 5 times negative 3 is negative 15. So this is our h prime at x. Going to finish our little bit of algebra here, right? Going to finish our algebra here, which is just to combine like terms. So we're going to simplify this. Simplify. Going to simplify this, and we have 20x squareds here, 10x squareds here, which is 30. Let me write it in yellow so we can see what's going to happen here. I'm hoping, this is what I'm hoping. I'm hoping we're going to get this thing back. So isn't it true that h prime at x, the first derivative, is 20x squareds plus 10x squareds is 30x squareds, isn't it? 8x's, there's no other x's together, so plus 8x's, so we use that. And there's this negative 15, and there's that negative 15, isn't it? So minus 15. So we use the product rule to prove this thing out. Now, let's stop and talk about this obvious question, where the obvious question might be, well, why the heck wouldn't you just always FOIL this out and then, or distribute this or expand this, however you want to describe that, and then use the sum and difference rule? Well, you may on some, but if you think about a function where you have like 3x times sine squared of x or something, it might be much, much more difficult to actually expand it out. It might not be possible. So that's why sometimes it's not possible. This is a great rule, and I want to be clear to all the students who are in AP Calculus. This rule doesn't show up on the AP test. The application of this rule shows up. So don't think that you're going to sit down for the AP Calc exam and have them say, find the first derivative of this. No, they're going to give you some function, and you're going to realize, oh my gosh, this is a derivative question, and then you have to have your little tool bag there and say, okay, how might I take this derivative? Maybe I'll use the power rule. Maybe I'll use the constant rule. Maybe I'll use a constant multiplier rule. Maybe I'll use quotient or product or the chain rule. So there are lots of tools you have to gather, and you've got to be really good at all of them, okay? All right, you guys, great work. I appreciate your comments. Thanks.